Code please.
Welcome to the second part of the second video, where we discuss basic types and operators. In this second part, we're also going to discuss a little bit about variables and assignment, and modules and functions as a way of organizing our code. We'll also take a look at some finished examples of real code. I know, it's all a bit confusing. Don't worry. Let's talk a bit about variables and assignment. It's quite common to store some data in temporary places, so we can reference them later in our program. We call these items variables. Assigning a value to variables in Elixir is done with the match operator, the equals sign. I'll explain later a little bit more about the match operator and how powerful it is, but for now, let's do some experiments here. So let's say I want to assign the value 1 to a variable named a. So I would do a equals 1, and IEX or Elixir returns me the value of this variable. Now, later if I reference this value, I always get the same value. So I'm assigning effectively the integer 1 to variable a. So the obvious next step is to try some operations. Since we can assign some values to variables, we can also do some operations with them. So if I assign, for instance, b, if I assign the integer 2 to variable b, I can later do stuff like this. So I can just say that c equals a plus b, and you guessed it, you're going to get 3 as a result. Another common operation that we sometimes want to do while programming is putting the value of a certain variable into a string so we can format some output. Let's say I want to write hello Pedro, but I want this Pedro to be a variable. So one thing I could do is say message equals Pedro. And then I could do something called string interpolation, which means I can inject some variables into a string. So I could do hello, and I can reference my variable like this. And effectively what Elixir is doing here is replacing that message with its value and returning a new string that is composed of hello Pedro. Okay, so far we've seen some basic types, we've seen some operations that we can do, some common operators, and variable assignment. Now let's go a little bit further and see how we can organize our codes in Elixir. So the way you organize code in Elixir is by writing modules, and modules have some functions, and functions have a certain number of arguments. I like to think of modules as responsibilities of a piece of code. So let's say I can define a module. I'm going to name it my project.myModule. Don't worry, we'll do some more concrete examples later on, but this will suffice for now. So I'm defining a new module, and inside this module I'm going to put a function called hello, and I am going to accept a single argument on this function called message, and inside this function I am going to just output hello, and like we did before, interpolate whatever we pass inside this function. And I'm missing a double quote here. And then I need to obviously close the function and close the module. And when I do this, basically Elixir is compiling this module into memory and into the Erlang virtual machine, and it's now available project-wise. So I can now just go and say my project.myModule.hello, and if I pass in my name, like we did before, I get hello Pedro. So a little side note around modules and functions. Elixir contains a very interesting function called h, which stands for help, that we can use to query about existing code that we have compiled, also including the base code that comes with Elixir. So we could, for instance, know about what does the div function do, and we know that div accepts 2 arguments because we used before. So we could do help div /2, basically arity2, and Elixir is going to tell us all the documentation surrounding the div function, including examples. So you can use this to query Elixir about pretty much any code that you have compiled to the virtual machine, including all the base code. So now that we know a bit more about modules and functions, let's write another module, this time with a function to calculate whether or not a number is odd. So we start by writing our module, and let's keep the same naming that we had before, my project. Call this my math. And let's define a function named odd and accepts one parameter, which shall name number. And inside it uses the remainder function that we used before to check if the remainder of the division of that number by 2 is 0. That means it's odd. And we close the function and close the module. And now we can do my project.mymath.odd, and we can ask, for instance, if 3 is odd, and it's not. And is 2 odd? It is odd. The question mark in the end of the function is a perfectly valid character to have in a function name, and it typically means that this function will return a Boolean value, either true or false. It's like a common practice in Elixir. Now let's try to code a simple calculator. So def module my project, I can type .my calculator. I'll define the addition of two numbers, n1 and n2, as n1 plus n2. I'll define the subtraction of n1 and n2 as n1 minus n2, and so on and so forth. Let's do mult, and let's close our module. A couple of notes here on this module definition. You might have noticed that I'm defining the functions with kind of a shortcut way. Instead of doing def function parameters do and end, I'm actually doing comma, do, colon, and this is short to define a function. And it's typically used for when you have a function that only does like a one-line operation. You can use this short syntax to write less code, basically. And the second note is that even though we're defining a div function, and you saw that the div function exists in kernel already, there's no problem because we're defining this in our own new module. So you can have the same name of a function as long as it's in a different module. So having our calculator ready, we could do my project.myCalculator, and I could do like add 1 and 2, and I get 3, obviously, and the same for the other functions. And now this is a good time to explain that functions in Elixir are actually first-class citizens. So we can treat functions like we treat other types and variables, which means that we could rewrite our calculator in a more clever way. So we could define it as such: def module my project.myCalculator2. Let's create a new one so we don't mess up the other one. And I can say that it's comprised of just one single function named op, accepts argument 1, argument 2, and it takes in also a function, which is actually the operation that we want to perform. And then we can define this as calling the function, and this is the syntax to call a function in Elixir dynamically. We do func dot and we pass in the arguments, and then we can just close our module. And if we did things right, we could do something like this: op 1, 2, and then we can pass an anonymous function here that performs the operation that we want. So let's define an anonymous function that takes a couple of operators. So here the arity is important, or the number of arguments is important. It needs to match the arguments that we are calling the function with. So if you take a look at line 6 over there, we do colon func dot and then n1 and n2. And this anonymous function needs to have the same arity or the same number of arguments so that it can be called later on. So we define this function as having the parameters n1 and 2, and then we define the body of the function, and we do n1 times n2, and we end the anonymous function, and then we close the operation. And if we execute this, we get an error. Why? Because it's not my calculator, it's my calculator 2. And we do 1 times 2 equals 2. So, and we can try that this actually works. So if we try to do like, imagine 2 minus 2, we should get 0, right? And there's another shorter syntax for anonymous functions. We can also do, instead of this longer, more descriptive version, we can do this. And then we can say argument 1 times argument 2. And this is exactly the same thing. We're doing now 2 multiplied by 2. It's a short. You can also have parentheses here if you want, but you can choose to omit them as well. So we could go like this, and you should get 1.0 because you're dividing 2 by 2. Okay, that's the end of the video. I know it was a little bit longer than last time, and it is a little bit confusing because it's supposed to be part 2 of the second video. But the reason for that is when I recorded it, I recorded everything in one go, and then later realized that it was actually too much information to show in one small video. So I hope you enjoyed it, and on the next video we are going to explore a little bit about function recursion by implementing the Fibonacci sequence in Elixir. See you later. If you liked this video, please consider subscribing and liking and sharing with your friends. It really helps the channel to grow. Thank you.